Welcome to this new video. In this video, we're going to keep practicing evaporation. And this is going to be a short video because we only have two problems to solve. So let's get started. This problem says, compute the weekly evaporation from a Class A pen if the precipitation and water added to bring the level of water in the pen to a fixed level are as follows. The as follows refers to these values here in this table. Now I have a couple images here to show you how a class A pen look like. This is a drawing. I don't know exactly if these dimensions are the same for every single one of them, but they seem about the same size as this one that I found. And they are placed usually right next to a lake to try to represent the lake and see how much water is being evaporated. Also notice this palette underneath. Uh, that palette has a very special purpose in the Class A pen as well. You can search more for or look for more information about this. So let's continue. It says compute the weekly evaporation. So what's happening here, these are the values of rainfall, water that is falling into the pen, and this is the water added. So we can keep the same level of water every time. So let's in week one we didn't get any rainfall, so any water into the pen. So we needed to add zero point 0.9 inches into the pen to keep it at a certain level. We don't know what that level is, but we don't actually need to know for this problem. So all we need to do now is find the sum of each week, and in a here I think it's gonna it says water taken from pen. This is negative because we got too much water in the pen, so we need to take out some water. Um, so these are our values that we get for each week, and that's what we need to do for part A. Now for part B, if the pen evaporation coefficient for this period of time is 0.8, coefficient 0.8, and an adjacent lake has a surface area of 150 acres, what is the evaporation from the lake expressed in inches and cubic feet for the 4-week period of time? So if you remember our equation, I think I have it in the next problem. Let's just copy and paste that. So this is our equation, right? Evaporation of the lake equals the coefficient uh, precipitation times the evaporation of the pen. So that's all we need to do. We have the coefficient CP and we have the coefficient, the evaporation of the lake. These are the values here. But we need to do it for this period. What it means is like for this whole period, like let's say for a week, for the whole month. So we need to do the sum. Let's say EP is gonna be equals to the sum of all these values, the four of them, and that's what we got. So like is gonna be equal to the coefficient times the total evaporation. So according to this Class A pen, we had a 3.56 inches of evaporation in the lake. 3.576, 576. So let's just make this, where is it? Here, 3.58 inches. So that's in inches. We need to find now the same value but in cubic feet. And since this is depth in cubic feet includes the area, we need to multiply that value of 3.58 times the area, which we're told is 150 acres. So we need to get rid of acres. So we're gonna multiply this by 43,560 square feet, 560 square feet divided by in 1 acre, and then multiply to get rid of the inches. In 1 foot there are 12 inches, and I believe that should give us the value in cubic feet. Yep, that checks out with my answer. Um, let's see if I can change that. So that's the answer in cubic feet. Um, so that's part B. And then how can the evaporation volume of this lake be reduced? Um, well, one of the big reasons water is being evaporated is because all this water is exposed to the atmosphere. So a great way to reduce the evaporation is to reduce the surface area. Um, and we can do that by building deeper reservoirs, right? Assuming this lake is actually a reservoir, if we make deeper reservoirs, we're gonna need less surface area because it's gonna go deeper. So this radius is gonna be smaller. So the less surface area will produce the less evaporation. Now let's move on to the next problem. And this is, we're gonna use this same equation. This is very simple. It says 1 month of rainfall and pen evaporation data have been collected, and a correlation to a mass balance for lake evaporation is attempted to determine the pen coefficient. The lake evaporation was 6.4 inches and the pen evaporation was 9.3 inches. So we have the lake evaporation and the pen evaporation, and we're asked to solve for the pen coefficient. Super simple. All we need to do is the pen coefficient is going to be equals to the lake evaporation, which is 6.4 divided by the pen evaporation, which is 9.3. Oh, forgot the equal sign. And this doesn't seem right. Or maybe it does. Let me see. Okay, yes, it is correct. Let's make this. So the pen coefficient is 0.69. And since it is a coefficient, it's inches over inches, this is unitless. And this is the answer for the second problem. And these problems are just a great way for us to get familiar with what the class A pen is and how it works to determine the evaporation in a body of water. Well, good luck solving this problem. See you in the next video.